let's see how much we can get done today on this new project, ROR clone. Yeah, it's a good enough name. Alright, there's our empty directory. Okay, so I'm gonna start with well, creating a directory, I suppose, another one. With a C file, and so I'm gonna start with a template, which is this one. Alright. There it is, 600 lines of code. Okay. Okay, can we create file? Control Alt plus Windows plus N. Wow, that is interesting. Wait, hold on. New file. Oh, there's two of these. Interesting. Huh. Build.bat. Okay, can we move it out? We can. We can move it out. Okay, clang code ROR clone.c build. Let me just disable preview in OBS. Okay, build ROR clone.exe. Yeah, that's good enough. I'm gonna have to define the task though. VS Code, is it? And tasks JSON. Problem matcher. Oh yeah, problem matcher. That's gonna be interesting. Type process. Command build.bat. Well, I mean, I guess it's that really. Build group build, yeah, presentation, whatever. Problem matcher, you're gonna have to define that. Okay. There it is. So it does not create a directory for us. Of course not. So I'm gonna have to create it myself. Okay, that works. Now debugging. Well, I mean, it's not gonna be here. It's gonna be here. Create a launch JSON. Yeah, LLTV. Yeah. Workspace folder, build ROR clone.exe. Let's add debug info. There it is. Yeah, VS Code kind of takes a while to terminate a task. Yeah, just when the amount of time that passes between the task terminates and VS Code thinks it terminates, it's just something else. Okay, can we debug it? Yes. Okay. Good. Does it work? It does. Alright. Well, good start. I'm gonna have to, hold on, let me just to do, I'll link this somewhere. Alright. Yeah, that's fine. Yeah, but probably std.def, I mean a std.def we can leave. Okay, intrinsics. That's where debug break comes from, alright. Yeah, this one. Let's see how it works out. Let's change it to lowercase. Assert x equals 1 int x. Okay, so that's not jack. Hold on, I didn't enable any warnings. All extra. Alright, okay, well, we get a number of problem matcher. We don't have a problem matcher. Okay. Alright, is there a way to just create a... Now I'm gonna have to look at that. Alright. VS Code problem matcher. Yeah. Problem matcher. I want a custom one. Yeah, that. That. Owner. Well, clan, I suppose. File location. Yeah, that's fine. Does that just work, by the way? Oh, yeah, it does. Alright, good. Okay, so we got unused arguments and unused, comparisons of integers. Okay. Well, the problem is it doesn't highlight this as an actual error. I think we can just modify it like that. And that will work. Yeah, so that actually highlights it as an error. And using the result of assignment in a condition without parentheses. There we go. Yeah, that's what I wanted. Alright, so that assert definition, I'm fine with it. Yeah. That we probably don't need. Well, string has memcopy and stuff, so probably leave that. Yeah, probably leave these two. Math, yeah, math we don't need. I mean, even memcopy we don't need that much. But honestly, I mean, yeah, you know what, let's remove both of these. Although, I mean, the thing about memcopy is that Clang will insert it anyway. So, like, there's no real reason to replace it. That will leave, okay, well, the compiler needs to go. All of this we can't avoid. Yeah, that's fine. Might as well leave those macros. Fatal error. Okay, where is it called? Fail to resize swap chain and fail to present swap chain. I mean, why not? Why not? Just leave it. Message box. Icon exclamation. And then exit with a 0. Yeah. I mean, exit codes, nobody cares about them anyway. Might as well exit with a 0. Yeah, we really don't need to do much here. basically just call default window proc, because default window proc will not post a quit message. So we have to do it this way. Okay. Okay, another thing I want to define is unused. Let's move these defines up here. Let's move these. I mean, this is kind of a platform thing, I suppose. Let's move this up here. Define unused. Thread instance, and then cmd line and cmd show. Actually, can I just not have them here? I think that'll still work. Oops. No, because when main is actually defined somewhere, so it has to be this way. Fair enough. Okay, register window class to have custom window proc callback. Well, yeah, we know. No, we know that's what's happening. Assert atom. I mean, this is fine. I mean, I'm guessing this atom isn't actually used anywhere else, right? Yeah. So let's just scope this. I mean, we do need window class. We do need window class. I mean, I guess, why not just put this here? Yeah, I just wanted to scope the atom out. Window class is fine. And this is an awfully short class name though. Window class. Okay, is this still working as expected? Yeah. Yeah. Yeah, that's fine. Let's change that naming convention. Let's change that naming convention. Window properties. Well, okay, so width. Can we actually can we lean on F2 to real like window width? Like, okay, that worked. Window height. There we go. Okay, now we don't need the comment. Okay, now redirection bitmap. Okay, well, we are gonna use the fluid presentation model, so we are gonna use it. Note. According to Martins. Okay, again, X style, window, X style, window style, okay, we don't really want a fixed size window, so, okay, well that is a window. Except that this is really an H-wind. Okay, create new window XW. That is the X style. Okay, so I'm guessing Windows style isn't actually used anywhere, so we might as well just pass it like that. Yeah. EX style, I'm guessing, is also not used anywhere. X, Y width, height, leave them on the same line, whatever. And then yeah, everything else we don't really care about at all. Okay, these are just names. So it's style, then names, then style. Create window. Well, a function called create window will do that, yeah. Okay. Is it still working? Yeah. Alright. Okay, so here's where the real fun starts. Alright, device, context. Well, yeah, we know. Yeah, this H result. I don't want to drag it around like this. Okay. If debug, then add this flag. I mean, do we really, I mean, this is, yeah, we don't really need that command at all. Yeah, that's fine, feature level, yeah, whatever. If not defined and debug, as in if it is a debug, right? Is this actually, are we hitting this? Yes. Yes, seemingly we are hitting this. 0x2, yeah. Okay, feature level 11, create device result. Well, yes, we know that's what that is doing. For simple applications, you could retry device creation. Well, yeah, I don't think we can, like, if we can't create a device, we can't run. So we'll just crash here. P adapter, driver type, software, flags, that's debug, feature levels, array size. I mean, I'm guessing array size is from Windows.h. Yeah. Actually, how is it defined? RTL number of v2. Size of RTLP number of A. Unaligned T address of and template extern C++. Well, we're not really in C++ territory. Like, you know what? Define array count x would be size of the array divided by the size of the first member of that array. Probably need to wrap this though, like that. Yeah, so we're just gonna replace all of these array sizes with array count. Okay, so immediate context is that context thing. Device, so these are return values. Yeah. Okay, does that work still? Yes. Okay, we don't really need any of this. Okay. If in def and debug. So if for debug builds, okay, more debug stuff. Okay, I don't think that's even true, that comment. Oh man, this is really weird, right? It's like we are loading. Okay, I'm guessing this is only used here. Yeah. Let's scope it. Okay. Does that compile? Compiles. Okay, so we're just setting corruption, error. I mean, I guess we can add warning here as well. Corruption, error. Warning. We shouldn't be getting any warnings as of yet, right? Yeah, although well, we can't really see the output here. Session. Well, I mean, I guess install open file and save. Okay, so we open this file, but then we also need to tell it to use this executable. Copy path. Command that. Display name. That. Our working directory is gonna be one up from that. Yes, let's run it. It runs output. Output is fine. Okay, not seeing any errors except these ones, but these are always there. Close. Okay, so there's all sorts of issues here. Process terminating. Please call report live objects. Yeah. Alright. Create the swap chain. Well, yeah. Leave this here. Okay, well, this is pretty obvious. I mean, I'm just calling this to yeah, I mean, yeah. Man, this is such an arcane series of manipulations. Like, first we use the device to get the DXGI device. Then we use the DXGI device to get the DXGI adapter. Then we use the adapter to get a factory. Why is it like this? Who knows? And all of this is to get just to get the swap chain. Just to get the swap chain. Okay, so that is the swap chain description. Yeah, we don't really... RGBA unorm. That sounds right. Flip. We don't want MSAA. The XGI usage and the target output. Yeah. 2 buffers. Scaling none. We don't want any automatic scaling of window content. Yeah. Flip discard. Yeah, I think that's what we're meant to be using. That's the description. Okay, now we're using the factory to create swap chain for H-Wind. Result. Oh my god, result. There it is. Yeah, disable. Yeah, that is a good one. No alt enter. And release some of this stuff. Okay, it looks like we are fine. Echo off. Okay, now vertices, yeah. Well, this is gonna have to change a lot. Buffer. So yeah, so this is the vertex buffer, which will essentially just go away. Create buffer. Okay, so we're ignoring, so this returns an H result, but we're ignoring that because of our debug layers, presumably. It's yeah, so it does return H result, but we don't need to worry about that. Actually, let's verify it. Can we verify it? Modify pass. I think that is incorrect. Yeah, so it does kind of work. Is Remedy any better at catching that? No? I mean, we do get the error down here. Okay. How does Visual Studio handle it? How do I even launch it? It's like, what is it, devenv? executable, attach whatever, working directory, alright. That is the working directory. Can I close this? Can I close this? Yes. Okay, what is the button? Start without debugging. Start debug. Well, start debugging, sure, but okay. Well, oh my god. There it is. There's the call stack. PTV not loaded. Can you load it? Load symbols. It loaded the symbols. Can we load symbols for that as well? External code. Okay. Okay, well, Visual Studio correctly stopped. What's this? Hot reload. Oh my god, that is yeah. Start live share session. No. Unhandled exception in whatever exception settings. Well, I mean, ideally you'd get an actual like, this is where the exception happened, not here. It happened here. Okay, so the location is just not correct at all. I mean, I didn't compile it with CL, so, you know, that's probably why. Do I have to resort to compiling with CL just to get better debugging experience for this? Load symbols. Oh yeah, we do get some symbols. Source not available, but we do get function names. Create buffer pre-validation, create buffer validator, validate. And debug, see interface sentinel, see function sentinel, report message. Okay. Sure. Why not? Okay. And then just, okay, so the location is wrong, which is interesting because, okay, oh god. Can we break, just break it? Okay. Okay, so remedy just doesn't pause at all. LDB does break in assembly somewhere. And then you have to like find the location, but at least the location's correct. So that's something. And we do get the assembly for it. That's it. Visual Studio just tells us source not available. See, the problem is Remedy gives us the output, like all this stuff. LLDB does not give us the output. Visual Studio gives us the output here, but it does not give the correct location for where the error happened. Now we could also use Microsoft Debugger in here, which will probably give us all three. But then like syntax highlighting will break. So yeah, all right. I guess we're just gonna have to use 3 debuggers, and you know, each of them gives us something different. Each of them partially works, and together they almost form a functional debugger. Well, I mean, I guess even just remedy and LLDB together give us a functional debugger. Because the only thing that's missing from LLDB is this output right here. I mean, it is weird that remedy just doesn't stop, though. Like break enabled, and yet it didn't break. Of course we could... Oh, what is this? What is this? Is it... Did we quit it in all 3 debugger? Yes. Of course we could do this. And then presumably... Well, this is still stopping. Yeah, this is still stopping in the correct place. Remedy, meanwhile, now stops at assert HR, so that's something. And Visual Studio, well, presumably Visual Studio will work in the same way it worked before. Well, actually it does stop in the correct place. Huh. Where is the output? Where is the... output? Okay, let's move this like here. What is this? Call stack. Okay, this is not very useful. This whole thing is not useful. Close. Alright. So there's the call stack. There's the watch window. I don't know what this is about. Diagnostic tools. Yeah, let's not with the diagnostic tools. Let's probably move this. Hopefully it won't crash when it didn't crash. Okay, good. A call stack output. Okay, well this is probably okay-ish. Yeah, I mean it launches pretty fast compared to this. I mean that's also not very slow, but mainly it's that it stops in the right place. The problem is that I'm gonna have to like find the correct place every time. That's kind of annoying. Well, anyway, so I think we can make it work. I think we can make it work. Yeah, so all 3 debuggers are kind of working. None of them are working well. Okay, fine, alright. Shaders, yeah, these are gonna have to change as well. These much must, well, yeah, I mean that's the point of the description. Semantic name, semantic index, format, input slot, aligned byte offset, input slot class, instance data step rate. Yeah, well, this is not really an instance thing, so... Yep. Okay, so this alternative is what we're gonna have to enable. Enable this alternative. Okay, flags. Okay, Matrix column major, strictness, warnings, yeah. I mean, yeah, maybe I have to change this to that anyway. So this doesn't matter too much right now. Error. Okay, so this is one of those. Failed to compile, failed to... yeah, this will go away. Well, I mean, I suppose we could just make this work now. Oh yeah, I didn't fix the vertex shader. Yeah. Okay, so that does work. Wait, hold on, do we get errors or whatever? No? No, we don't. Close. I guess there are some live objects, but we're gonna fix those later. Well, actually, yeah, let's fix the live objects and then see about this stuff. Buffer, texture view, sampler. Like, we're gonna need all of these, just like different versions of them. Buffer, also known as a C buffer, apparently. Blend. Are we gonna need blend? Yes, we're gonna do some blending. Blend, rasterizer, yeah, we're gonna need that. Disable culling. Well, yeah, I mean that's what that does. We know. Okay, all of these things return H results though. Like that, and that, and that. Okay, so we show the window here. Okay. Depth state. Disable, well, yeah, I mean, enable false means disable. Actually, we're not gonna need depth for this. Yeah, we're gonna be removing depth. We're not gonna be removing all of this other stuff though. Okay, yeah, let's just keep going here. Show window. Large integer. Okay. Counter and frequency. Yeah, that's just for timing. Okay, so freak is... well, I mean, we're probably gonna remove that, actually. Direct 0 with Python. Get client rect window with that function will actually not work sometimes. Okay, where are these warnings again? Here. So just which of these is D word? I mean, if we're gonna keep these as D words, then we might as well make these D words. Okay, no warnings. Finally. Well, no warnings, but like some exceptions that we don't control. Create device. Oh, we're already here. Okay, no warnings, I think. Process X, yeah, this is where it started. So if we step over that, then this is where the exceptions are thrown. Even though this result is success. Yeah, alright. Amazing. Okay, do we still need this? Yes, apparently we do. Ah. Okay, so once we... Alright. So let's create a file. Oh, that is a lot of stuff. Wow. Alright. Create a file which is gonna be what? Rourke clone HLSL. And it's just this code. Yeah, whatever. Paste it in. Okay, so what's all of this? Okay, I don't care about this output. I don't care. That we don't need. I don't just stop. Okay, C buffer, U transform, yeah, that's gonna go away. Sampler, texture, okay, vertex shader, pixel shader. Okay, well, we're not compiling this. Which we will. Now. Okay. Well, let's see what this actually does. FXC. Oh god, how do you like that? Yeah. Alright, well, let's see what we're doing with this FXC stuff. So we just want the debug build for now. So no logo works. Target profile. That's VS 5.0. Yep. Entry point name VS. Entry point name PS. Okay, so this optimizations, we're not doing those. WX. Well, we're actually doing OD, if anything. Disable optimizations. Disable pre-shaders. Okay, I don't really know what those are anyway, so we got treat warnings as errors, Disable validation. Okay, I don't think we want that. Enable debug information. Yes. Debug name with source information. Debug name with only binary information. Back matrix is in column major. Back matrix is in row major. Okay, well, yeah. Well, let's actually let's do RAM. Remove ZPC. Partial precision. What we have got? Guess strict mode. Okay. Disable effect performance mode. Okay. FH. Oh yeah, so we are actually outputting a header file. FH. I reckon I'm just gonna name these ROR clone PS PS. So let's just encode the file name, why not? And then this is gonna be like that. Yeah, I think this is pretty obvious. So file name entry point .h. Global shader. Okay, strip, qstrip. Preprocess to file. Qstrip, strip reflection data. Okay, I don't think we need to strip anything. Debug. Qstrip priv, strip private. Let's not strip anything. Yeah, let's keep it all in. Code. ROR clone HLSL. Yep. This is okay. Does that work? Yes. I mean, of course, it's chatty. It wants me to know that it succeeded. Okay. Well, it created these files here, which we don't need. Let's put the output in code. Okay, so in code, they're fine. That's where we want them. Now, okay. Include clone HLSL, ps.h, and vs.h. Okay, so this D3D11 V shader. Okay, let's just remove that. Okay, well, this probably, I mean, well, to be fair, this would make them local, and it will put them on the stack. Well, as local variables, right? Unless, of course, I mean, it generates let's see, what does that generate? Const byte array, right? Yeah, I don't know where the compiler is gonna put that const byte array, so let's just make them global. we're not gonna have that many shaders, so I think this is fine. We know that that's gonna go into the executable. Okay, so we'll D3D VV shader. This is global shader VS, and this is global shader VS. That. Okay. Well, let's see. Okay, that did work. It did work. Of course, we're gonna have to verify that it actually worked with another debugger. Like, well, even that one will, yeah, will do. Yeah. Okay, that's. Okay, so now that we're using these shaders, let's see. Can we get rid of this HR thing? Well, multiple things, right? First we need to remove that, but we also need to make sure we can actually debug it. Debug the shaders. Okay, executable path is that. And working directory is that. Launch, oh my god. Yeah, you know what? I allow access. I don't care. Capture. Draw. Oh my god. What is that? Oh, that's the depth and stuff. Texture viewer, mesh viewer. Can get mesh viewer. There we go. Debug this vertex. Okay, it's debuggable, which is what I wanted. Okay, so the debug info is working well. Let's see, can we remove this? Ah, so this is buffer resizing. Result. Change to full. Well, yeah, that does make a lot of sense. Yeah, I don't think this is actually true. Like, that's just not how that works. Like, if we put a breakpoint here and run it, and then minimize the window, this doesn't. Like, status is not occluded. Status is just success. Like, it's presenting minimized windows. Maybe Windows 11 changed it. Alright. Yeah. What else do we got? Remove the depth stuff. Well, let's remove the triangle. Let's remove the triangle first with the constant buffer. Well, let's start here, I suppose. Set up this matrix. Okay, we don't actually need this matrix at all right now. clear. Yeah, that's clear in the target view. Yeah, we know. Depth, remove that. It's primitive. That's fine. Oh my god. Yeah, that does make sense. This delta isn't used anymore, so let's remove it. Okay, clear view, set layout, set topology, then set vertex buffer, which will go away. Vertex shader, rasterizer, pixel, output, draw. Yeah. Resizing. Oh my god. Okay, well, let's see. Clear state, release, release. Okay, and then window width, window height, resize. Create a new back buffer, apparently. I mean, it's created and released immediately. That's depth description. Oh yeah, so that's the things that gonna have to go away. All this depth stuff. Alright, where's this angle thing? Angle's there. I don't think we're using these, are we? No. Yeah, this is just where we keep track of window width. Okay, well, like, why, like, if we're gonna recalculate these anyway, just might as well just replace these here. Okay, do we need math? No. Okay, so now we should we should have something. Yeah, well, we get something. Does it actually? Yeah. So now that we've removed, hold on. The shader still has it still has this transform thing. Yeah, let's remove it. Now we should get an error somewhere. Or not. I mean, is it somehow not an error to like create? Well, I mean, I suppose it's not an error to create a vertex buffer. But a constant buffer when we're not using it. Window class, window device context, swap chain, vertex, vertex buffer, layout, shader. Should I, like... Should I do this? I guess guess it doesn't take too much effort, so might as well. Yeah, well, there's that constant buffer. We don't need that, actually. Running? Yeah. That texture we also don't need. Yeah, well, I mean, it's not that we don't need it. We are gonna texture our stuff, just not with this texture specifically. But I suppose we'll leave it because we'll just replace the pixels. Unsigned int. Isn't that a U32? Where do I put the type defs? Just, we don't need that. Yeah, we don't need that. Where do I put the type defs? Actually, this stuff should probably go here. So these are just includes fragments. No, maybe put the fragments up here. Now we have includes defines. Okay, let's put type defs here, I guess. std int type def int 32 ti32. All right. uint would be a u32. uint. Yeah. '64 and 16. Okay, so now we have sensible integers. Unsigned int u32. Will that work? Yeah. Alright. So leave that, leave that. So let's verify that alt enter actually doesn't do anything. Yeah, it doesn't do anything. Depth state, yeah, we're not gonna have depth anything. We don't need depth state. Sampler depth rasterizer. Okay, so this depth stencil view. Like, we keep creating it for some reason, but I don't think we need it. Okay. Well, we're gonna have to go in here to see the messages. Random target. that's fine. Yeah, we still have some live objects to kill. Okay. Okay, so I think this is pretty much all of the, well, almost all of the DirectX code we're ever gonna need. Okay, let's clear that. Like, what to do, so, like, put this link somewhere. Well, yeah, I don't really know where it should go yet. Somewhere. Okay, is there anything obvious that I want to change at this point? We want all of this. We are gonna keep all of that. Keep all of that. Yes. Oh yeah. Matrices. We're not passing matrices anymore, so we don't really care about that packing. Yeah. Okay. And really what we, oh yeah. So instead of drawing triangles, we actually want to draw rectangles. And to that end, we need to okay, so this is the shader, right? So all we really need to draw is rectangles with textures on. So every rectangle is just gonna have the same coordinates anyway, because it's axis aligned. Well, we'll rotate them around, but we don't have any weird, like, non-rectangular shapes to draw. So float 2, I guess, vertices is, can I do this? Array of float 2s. So we're gonna start at -1, 1. -1, 1. Then we're gonna go to, well, actually, no, we have to start at -1, -1. -1, -1, then it's -1, 1. Then it's 1, 1. And then it's 1, -1. That. Those are the vertices. And this vertex is vertices. Okay, there's a global, like, SV vertex index or something. I forget what it's called. HLSL vertex index. SV vertex ID, that's right. That, I think. Of course, we need to define that as an input. So, is it an int or what? Well, let's see. Uint index. Okay, so we're not using this. Which is why I should probably still do this. Yeah, it's still running. Okay, now we, instead of using this input pause, let's use this vertex. Okay, there it is. Red, green, blue, well, yeah. Alright, so now in the input, okay, so VS input, I mean, we're still gonna have position and UV and color and possibly rotation of all the rectangles that we actually want to draw. So, except that's a per instance thing now, not a per vertex. So let's go in here. Position texture coordinate, well, texture coordinates, okay. Texture coordinates. I mean, it's not so much a texture coordinate as it is like where to find the texture in the texture buffer. Yeah, well, let's not worry about the texture so much now. Yeah, let's just pass it through. Because for like a real UV would be really more like there's some syntax error I'm seeing. I guess there was. Okay, so what would this be, like 0? Well, conceptually it's 0, 0, right? And then the top left would be 0, 1. And then we've got top right, which is 1, 1. And then bottom right, so 1, 0. So these are like the UVs. So instead of using this input UV thing, we are actually, this UV is UV's input index. It's just that. Yeah. Okay. Well. Okay, I don't really know what we're looking at here. Exactly. But something like that. What are we looking at? I mean, it's sampling the texture. there's like transparency involved. Hold on. U32. Let's just do something more obvious. 0x ff 0 0 0 0 0x ff, well, 0 0 ff 0 0 and 0x 0 0 ff, well, 0 0 ff like that, and 0x ff 0 0 and magenta, of course. Okay, well now it's not even here. Somehow. I just changed the colors. Oh wait, I forgot the alpha. Is it, what is it, like A RGB, RGBA? Well, we're gonna find out. Okay, well that's supposed to be red, so at least that part is correct. Now what's happening here, I don't really know. This part's like black. Okay, well, the pixels for the texture. Well, actually, is that part supposed to be red? Well, if our textures are meant to be like top down, then the first pixels would be at the top. So no. Well, let's go to render dog. Let's just see what is going on there. Okay. I mean, we're passing in. Yeah, so this is the VS out part. Yeah, this is what I expected, essentially. Texture coordinates 0, 0, 0, 1, 1, 1. Yes, that is also what I... Oh wait, it's multiplying the color by the texture. So all sorts of weird stuff is gonna happen there. Let's turn that off. By going to the colors. Yeah, color. Float for. It's just all ones. Okay, well, red, yellow, and then it's unclear what's going on there. Launch. Did it save? It saved. Mesh viewer. Draw. Out. Okay. Okay, colors all ones. That's the output. Texture coordinate, yep. Texture viewer. Okay, well that is the texture. Red, magenta, and then yellow. Red, magenta. Oh wait, hold on. I need to figure out where the alpha is. So it's just... I mean, that's not gonna... Yeah, that'll just tell me if the alpha is at the beginning. Okay, let's start here. So it should be all white. so now let's remove the last part, and if it disappears, that means that's the alpha. It didn't disappear. So it's not the alpha is at the beginning. Okay. Is it? Okay, so this first part is alpha. What's the first channel? Just have it. Blue. So it's well, there's the format, right? It's RGBA, but like backwards. RGBA. Okay, so this is the blue channel. So this is the red. Red and blue. It would be magenta, yeah. Oh my god. Okay, I don't need to switch away from it. So that's red. So it's RGBA backwards. I mean, that's fine. Okay, so now that we know what we're looking at, well, we need to draw the rest of the rectangle. And to do that, okay, so there's our buffer stuff. Layout, shader, piece, yeah. Okay, so first of all, V buffer isn't really a V buffer. I mean, it is. It's just we're passing in, for instance, data. And we're gonna write to it. So usage dynamic CPU access flag CPU access rate. Does that work? Yeah. Okay, so this is the data for the buffer. And let's just have two things here. One of them would be position, let's say. Let's say it's 0, well, 0, 0. Well, we don't really need that much precision. Yeah, I suppose, well, yeah, okay, 0, 0 and like 1, 1, something. UV, well, yeah, UV, you're gonna have to figure that out later. So right now, UV is, I mean, well, it is sampling from the texture. Which we don't really, well, oops, okay, well, both of these, yeah, no, this is fine. UV will eventually become something meaningful, but right now it's not so much. Are we using input UV? No, we're not using input anything other than index, not even color. So position, UV, and color, none of that is being used. Okay, position, I do want to get that working. UV and color can wait. Okay, position. UV. Color. Well, it's not clear right now what exactly I want the color to signify. So let's set this to zeros. I mean, I guess, okay, let's just remove it. Let's just remove it. Position. The only thing we need is position. And then in the description, it's just gonna be position. Oh my god. Position, it's gonna be per instance. And it's gonna be instance that's separate as 1. Byte offset is that. Okay, so semantic name position, semantic index 0, format, input slot, aligned byte offset, input slot class. Yeah, there we go. Remove that. So does that work? Yes. Okay. Does that do it? Okay, that's the same thing we've seen before. That's fine. So red. Then let's do that. Red, green, blue, and then magenta here. Okay, well, it's upside down. Because the first pixel is... So textures is, I guess that would mean that texture is bottom up. Yeah, the texture is bottom up. I mean, we can just say that our textures in pixels are bottom up. Okay, this corner rounding. Can we not with the corner rounding, like, I put pixels in there. That Windows is just rounding off. Not amazing. Okay, so red. Well, this one would be the other color. Green. Green is the one that we're not seeing. Red, green, blue, magenta. Okay. Okay, so just 2 of them. It's 2 vertices. So in the drawer, we just do draw instanced. Context. Okay, let's find out what the arguments are to that. Okay, can we not with this? Vertex count per instance. Well, that would be 4. Instance count is 2. Start vertex location is 0. Start instance location is 0. Yeah, we don't really need to step away. Okay. Well, I did ask it to draw 4 vertices. Okay, well. Triangle list, yes. Don't do color. Okay, let's look in render doc. What are we actually seeing there? No. Just don't save anything ever. Mesh. Yeah, so there's our texture. That looks great. 1, -1. So that would be here. Oh wait, let's try not primitive topology is wrong. Hold on. Triangle strip. Well, okay. Maybe not strip. Okay, which? Well, let's look at it. Yeah, so it's drawing in them like that. 1, 2, 3, 4, which is okay. Let's just so -1, 1, -1. Wait, we need to start at the top, right? So go in a Z, which just means move this down like this. -1, 1, 1, 1, 1, 1. No. -1, 1, and then 1, -1. Okay. 0, 1, 1, 1, 0, 0, 1, 0. I think that's it. Alright. Yeah, that's what I expected to see. Except that we have 2 of these rectangles, and I either want to draw both correctly, which means passing in not just the position but also the scale, right? Well, a scale or size or something like something to transform them. I suppose for now this could be scale. Extract v2 f32 x y. Type defs. Type def float 32 double 64. Abstract vertex. V2 position. I mean, that we're gonna need that for sure. Okay, so that's the same thing we've seen before. Scale. Let's just pass scale in. Why not? Times input scale. Plus position. Yeah, let's just do that. See how what that gets us. Yeah, well, scale is gonna have to be named scale. Format's fine. That's scale right here. Per instance, yes. Yeah, well, let's see. Okay, well, so one of them is in the center, which is what we expected. The other one's up in the corner, which is also what we expected, because the center of it moved up there. Yeah, and everything is happening in this clip space right now, so we're not transforming coordinates any other way. So that is actually fine, except that let's change this probably to 0.5. Okay, well, we've got two rectangles, each with the texture. I mean, each of them fully displays the texture that we have, which is not really meaningful, but it will be. And really, this is where is it? Clear and target view. Okay, I don't really. What is this color we're clearing it with? I don't really get it. Let's just change it to. Let's clear it with all zeros. There we go. Yeah, this is most of the rendering. Okay, let's change the title of the. Yeah, this is most of the rendering we're gonna need. Just rectangles with textures on them. So let's commit that. Alright, well, initialize repository, yeah. Okay, we're gonna get a git ignore. Yeah. Okay, we'll ignore everything except itself. And I guess I can just add it, right? Like git add or something. Like what's the? Is there a, no? Git add build git ignore. Yeah. Okay, well, we don't need temp or whatever, so temp anything is just not ignored, not included. .vs code is also not included. I mean, I guess code HLSL underscore anything like that. Should not be included. Build a button. Okay, so I think everything else is pretty much what we want it to be. Okay. Well, stage them. Stage changes. Create D3D11 window, pretty much. Publish, or publish, public. Yeah, that seems fine. Alright. Well, that's all for today. Thanks everyone. See you later.